Hello students, how are you all? Now we continue with the yesterday's lecture. Yesterday we had been discussing about estimation theory. So estimation theory is nothing but one of the wings under inferential statistics. Inferential statistics has been divided into two areas. One is called testing of hypothesis and one more thing is theory of estimation or else estimation theory. So yesterday we came to know about what you called estimation theory, like what are those, what do you mean by estimation, what do you mean by an estimator and estimate. An estimator is nothing but the formula, like arithmetic mean formula, geometric mean formula, median formula, mode formula. So all these formulae are known as an estimator. So when you substitute the values in this formula, you get the result. That result you are calling as the estimate. The process whatever you takes up to get estimate from the estimator is known as the estimation. So as far as the estimation is concerned, there are two types. One is called the point estimation and one more is called the interval estimation. What do you mean by point estimation? The point estimation is such a kind of estimation where actually you are going to provide a single numerical value as answer to the population. Let us suppose that the mean of the population, so you actually know very well, all the population symbols are going to be higher case alphabets or else what called higher case Greek letters. So contrary to that, all sample information is going to be in terms of lowercase alphabets. So what is the population mean notation? The population mean is represented by mu. So what is that? The population mean is represented by mu. So this is sampling theory. You need to accustom with these new notations. So the mu is equal to 20. The population mean is equal to 20. Now here the 20 is a single number. So such a way, if you provide a single number as your answer, you call such a kind of estimation as a point estimation. Pointedly you are giving the result about the population parameter. So unlike to that, if that mu value, I mean to say the population mean value given in terms of the intervals, lower limit, higher limit, you call such a kind of estimation as an interval estimation. The one more name is nothing but the confidence interval or else the fiducial limits. What is one more name? The fiducial limits. So how do you provide the interval estimation? For this example, let us suppose that mu. Now look at here, if this way if you provide the answer, you call such a procedure, such a method is known as the interval estimation. Why here? Here you are not providing the mu value as a single answer, but you are giving the range. Range means in between. You are expecting that the population mean is going to be between 15 and 22. This 15 is known as the lower limit. This 22 is known as what you called the higher limit. Such a way if you give the answer in terms of what you call the interval, that estimation is known as the interval estimation. Okay. So estimation is of two types. One is called the point estimation and one more is called as the interval estimation. So under interval estimation, what you are doing? You are pointedly giving a single numerical value as the answer of the population information. So population parameters are nothing but the population information only, that is population mean, population variance, population correlation coefficient, population regression, whatever may be. In the sampling theory, if you are providing information about the population, what you are calling as the parameter. So in the point estimation, you are providing a single numerical value as a parameter answer. But as far as the interval estimation is concerned, you are providing the gap, the range, the lower limit, the higher limit of what you call the population parameter. You may raise a doubt here. So if you see these ways of what you called estimating the answers of the parameters, okay. So by looking at these answers, one can say that the mu is equal to 20, that is the point estimation is going to be more powerful. Strictly speaking, not at all. If you compare the interval estimation and as well as the point estimation, the interval estimation is going to be what you call give more approximation about the population information. The precision is very less, but you are providing more confidence about the population answer. Hence, if you rate these two methods, point estimation, interval estimation, the interval estimation will be provided the rank 1. The point estimation provided the rank 2. That means if everything goes well, first you should prefer the interval estimation, next you should go for the point estimation. Understood? Now let us come to the information on the slide. So in point estimation, a sample statistic is used to provide an estimate of population parameter. A single information would be there. In interval estimation, that is the confidence interval or the fiducial limits, different names, probable range will be specified. Range means in between. Lower value will be there, higher value will be there. Probable range will be specified within which the true value of parameter might be expected to lie. Very, very important discussion. So how many types of estimations are there? 2 types. Point estimation, interval estimation. The estimation process can produce either a point estimate or else an interval estimate. So either way you can get the information about the population. A point estimate is a single value and has the advantage of being very precise. If you look at the answer, there will not be any kind of confusion. Such a way of providing answer is known as a precise answer. Now next, what is the example? So based on a sample data, you might estimate that the mean age for students at the state college is equal to 21.5 years exact. So only one single information was provided. So this is all about the point estimation. Now let us come to the interval estimation. So an interval estimate consists of range of values and has the advantage of providing greater confidence than the point estimate. So if you really thinks the technique whichever provides more confidence, that is going to be the effective technique. Hence the interval estimation is going to have more importance. For example, you might estimate that the mean age for student is somewhere between 20 and 23 years. So here in the interval estimation, we are providing the lower value and higher value. So note that the interval estimate is less precise but gives more confidence. That's what I told you. So if you want to prefer interval or point, always go for interval. So for this reason, interval estimates are usually called as the confidence intervals. So they are providing the confidence, the belief, because based upon that analysis report only the further decisions will be made. Hence, having the confidence in the results is very, very important. So that confidence is going to be provided by the interval estimate. Now we discuss very, very important criteria of a good estimator. So criteria means properties. This is a stock question. Every time you are going to get this question. So please be careful. So what do you mean by criteria of a good estimator? As you all know very well, what do you mean by estimator? Estimator is a formula. Let us suppose that you want to calculate average itself. To get average, how many formulae are there? Again, mathematical averages are there, positional averages are there, business averages are there. That is different. Let us take mathematical averages only. Under that, what are all there? Arithmetic mean is there, harmonic mean is there, geometric mean is there. So, three formulae are there under mathematical averages. But in these three formulae, which is the best one? Just like on the products, you will be looking forward what to call any ISI mark is there. So if at all ISI mark is there, AG mark is there, we feel that that's a quality product. Such a way, is there any quality measurement? Yes. To measure the quality of the formula, so these are the properties. One should follow these formulae, then only that formula can be assumed as the good formula. Estimator criteria. What you call that? Estimator criteria. Okay. So what are these? The first one is known as the unbiasedness. So what is unbiasedness? Next, consistency, efficiency, sufficiency. Understand? So these are all called the criteria of a good estimator. What do you mean by unbiasedness? So, generally if you speak, unbiasedness means impartial. No question of what to call showcasing partiality. But statistically, how do you define the unbiasedness? If the expected value of any statistic is equal to the population value, you call that a property is known as the unbiasedness property. Understand? So if any formula satisfies this unbiasedness property, then what you can say? Yes, that is a what you call a good estimator. Okay? Now I already told you there are so many formulae are there to calculate average itself. So the best example is, let us take arithmetic mean itself. If a data is there, for the data, if you want to calculate arithmetic mean, okay. So what happens? The answer, whatever you get from the sample information, is exactly most of the times very much nearer to the population information. This is most important. So let us see here. Look at here. Now here this big circle is the population. Now this small circle is nothing but the sample. Let us suppose that this big circle is nothing but all the supermarkets which are there in Hyderabad city. Understand? This small circle is nothing but in one area few particular what you call the supermarkets. If you want to know on an average how much business all these what you call the supermarkets of Hyderabad doing per week, per month, per year, like that, you need not to what you call take all the records of these supermarkets of entire Hyderabad. So what you can do here, you can pick few supermarkets from any one of the what you call the prominent locality. From those supermarkets data you can calculate the mean. Understand? So this small letter x bar is known as the sample mean, because this is the sample or what you call the subset of the entire population. Now this mu is nothing but the entire mean information of this big circle, what you call this population. Okay. So what do you mean by unbiasedness property? If the expected value of the x bar, that means the average of all these x bars is going to be the mu. What do you mean by mu? The population mean. Then one can say that formula is satisfying unbiasedness characteristic, unbiasedness property. So you need not to worry, understand, already these are all established proofs. So they ask you explain about unbiasedness. So how do you denote that technically? So here you observe. So this is called the unbiasedness property, what to call procedure. So the expected value of Tn is equal to theta. Then one can say that the formula is satisfying unbiasedness property. What is Tn? All sample values. The sample values, what you are calling the technical term statistic, not sticks, stick. So all sample statistic expected value is equal to the population value, that is the theta. Then one can say that a formula is satisfying the unbiasedness property. Get my point? So if you think such a way, every time without any hesitation, if you want to calculate what you call the average of the population, this big circle, so you simply take the sample, that is the small circle. From that sample information, you calculate arithmetic mean. Arithmetic mean, what is the formula? Sum of all the values by number of values for individual series. Like for discrete series, for what you call the continuous series, various formulae are there. So any arithmetic mean formula is almost equal to the value of what you call this big circle value, what you call the population information. That's why. So most of the times when the data analysis has been taking place, to calculate the average, we use the arithmetic mean formula. Understand? But remember that the sample variance is not the unbiased estimate of what you call the population variance. Be careful. That means whatever the variance is there for this sample, variance means variation, deviation from the average, from the mean. That information cannot be generalized to this what you call the population itself. Getting my point? So this is a very, very important example. So sample mean is the unbiased estimator for the population mean. But the sample variance is not unbiased estimator of the population variance. So to make into a unbiased estimator, some what you called a product term would be there. With that product, when you multiply, that value is going to become the unbiased estimator. That is beyond your level. So for time being, what is important? The sample mean is unbiased estimator for the population mean. That's it. Okay. Now next we go for what we call understanding about the consistency. Understand? So what do you mean a consistency? The consistency is nothing but that formula actually which provides information without any deviation. Understand? Then how to understand about the consistency? I'll have to look at here. So look at here. This is actually how to write the consistent estimator. Now here, how to read this? So limit n tends to infinity, probability of modulus of Tn minus theta greater than epsilon is equal to 0. This is the mathematical way of writing the consistency. You need not to worry, but still Once if you observe, it's very easy to understand. Okay, what do you mean by this? Means whenever n becomes larger, very big, isn't it? Then what happens? The information whatever you get from that sample is going to be almost equal to the population information. So what is the meaning of this? Tn means the sample information, theta means the population information. So the deviation should be what you called more than epsilon, means a very small. This entire probability should be equal to 0. What do you mean by that? This probability never should take place. There will be less difference. Such a kind of property is known as the consistency property. Right? So the best example is Poisson distribution. If you take the Poisson distribution, you know very well what is the Poisson distribution mean. The Poisson distribution mean is nothing but the lambda, isn't it? The lambda value is a consistency estimator. Understand, with that of what you call the population, what you call Poisson distribution, lambda value. So this is the way of what you call providing the consistency information. The next property is efficiency. So for only one average itself, you can what you call have different formulas, like a arithmetic mean way you can calculate the average, and even you can calculate by using median also. Both are averages only. And also both these arithmetic mean as well as the median satisfies unbiasedness and as well as the consistency. That means above two properties. Then it leads to confusion again to decide whether to opt the arithmetic mean formula or else what you call the median formula. Then actually the efficiency property comes into the play, isn't it? The efficiency property is based upon what you call the variance. The formula which leads to less variance when you calculate any estimate from the formula, I mean to say from the estimator. That formula, that estimator is known as the efficiency estimator. So the efficiency truly based upon what you call the variance information. The estimator which will have the less variance, such estimator is known as what you call the efficiency estimator. Here the best example is nothing but the sample mean. If you compare sample mean with that of the sample median, the sample mean will be an efficient estimator. Because while calculating arithmetic mean, what you are doing? You are taking the sum of all the values, whether 10 values, 50 values, 100 values, whatever may be. But while calculating the median, what you are doing? You are actually putting all the values in the sequence order and you are picking the information, those values which are in the exactly mid of the entire series of the data. That means you are actually not taking the importance of the extreme values. Hence the variance is going to arise. So that is what actually efficiency property means. So what do you mean efficiency here? The efficiency estimator is that estimator which is having the less variance. So the best example is, what is that? The sample mean with that of what you call the median. The next one is called the sufficiency property. What do you mean sufficiency? A sufficiency property says that any estimator should provide all wanted information. That sample information should provide all the wanted information about the population. Such an estimator is known as the sufficiency estimator. So a sufficient estimator is that estimator which contains all the information about the population parameter. Understand? So these are all called the criteria of a good estimator. Understand what are those? The first one is the unbiasedness, second one is the consistency, the third one is the efficiency, the fourth one is the sufficiency. Understand? But remember that no formula is there which satisfies all these properties. But any one formula which satisfies more than 2 or 3 properties, that estimator, that formula will be considered as the good estimator, as a good formula. Understand? This is a very, very important discussion. So let us go for information in the slides. So what is unbiasedness? If the average of sample values is equal to the population parameter, it is an unbiased estimator. That is, expected value of x bar is equal to theta. Then what is a consistency? A statistic is a consistent estimator of a population parameter if, as the sample size increases, it becomes almost certain that the value of the statistic comes very close to the value of the population parameter. So when the calculated value is very close to the population value, then what happens? The difference is going to decrease. That logic actually denoted by using the limit technique in the mathematics. So limit n tends to infinity, modulus of Tn minus theta value should be more than epsilon, should be equal to 0. So need not worry those mathematical notations, but better to understand that information. The next one is the efficiency. So if the variance of the estimator is small, the distribution of the estimator will be better, in that its value will be closer to the parameter value. So efficiency truly based upon the variance information. The best example here, the arithmetic mean is more efficient estimator than the median. The sufficiency. So this property actually, given to us by Professor R.A. Fisher. He was known as the father of the statistics. Okay, so Irving Fisher. There are so many distributions are also there developed by him. Student distribution, F distribution. So what he says that an estimator is sufficient estimator if it makes so much use of the information in the sample that no other estimator could extract from the sample. Additional information about the population parameter being estimated, which is a necessary condition for sufficiency estimator. Okay. The best realistic example for sufficiency is comparison between dictionary and encyclopedia. So in the dictionary, what do you find? Actually, the meaning of the word you find. But in the encyclopedia, you find the root word for that word and what you call any other related information regarding the origin of that what you call that particular word. So more extra information you find when you refer any encyclopedia like a Britannica encyclopedia. Understand? So the encyclopedia will be considered as a sufficient estimator as far as the knowledge is concerned. Same way, the formula, if you consider, which formula will be considered a sufficient estimator, which should provide all the information about the population. Okay. So here ends estimation theory. So estimation theory. So what you learn here? What do you mean by estimator, estimate, estimation? Understand? The criteria of a good estimator, what are those? The unbiasedness, consistency, efficiency, sufficiency, and also types of estimates. Like what is that? The first one is the point estimation, that means the single answer you are going to provide. The next one is the interval estimation. What are other names? The fiducial limits or the confidence limits. So you are providing the answer in terms of what you called interval, the lower limit and as well as the higher limit. Okay. So in the next class we cover what you called the information about the testing of hypothesis. That is more interesting, and there you got the problems. Okay. I stop here. Thank you so much.